Hello, AP Stat students. Today's lesson is continuing on the standard normal distribution, so I'll be using z-scores, but today's lesson is called inverse normal. So in yesterday's lesson, you were asked to find the percentage of the distribution that fell above or below a certain z-score. Today, you're going to be given the percentage or the percentile rank, and you're going to be asked to find the value in the distribution that is equal to that. So it involves solving for x in the z-score equation. So if you think about the z-score equation is this, x minus the mean divided by the standard deviation. In this unit, and really forever in this course, that is the only equation we have for the standard normal distribution. So if there's ever a question where the distribution is normal, that's the equation that we're going to use in some fashion, okay? So just keep that in mind. We only have one equation to work with here. So this question is an example. The life expectancy of a particular brand of light bulbs is normally distributed with a mean of 1,500 hours and a standard deviation of 75 hours. What is the 25th percentile of light bulb life expectancy? So, because it says it is normally distributed, that gives us permission right away to draw a bell-shaped curve. And it says that the mean is 1,500 hours, so I can write that in the middle. And the standard deviation is 75, we usually write that below. And then we're interested in the 25th percentile, which would be down on this end of the graph, okay, the lower 25%. So I want to know how long do light bulbs last in that region, okay? And I know that this is 25%. So again, I only have one equation. Okay, and let's fill in what we know. So the x is what I'm solving for. The mean is 1,500. The standard deviation was 75. And I'd love to have a z-score to plug in. But I don't know the z-score. They just gave me the percent. Okay, well, we can find that a couple different ways. We can find the z-score for 25%. One way is to use this table, okay? And remember, the z-scores are on the outside of the table, okay? The percentages are on the inside of the table, so in here. So what I'm going to do is I'm going to try to find 25% inside the table. And if you look very carefully, this is as close as I can come, I circled it in yellow, to 25%. If you look to the left of it, that's 20.2546. And you look to the right of it, that's 0.2483. 0.2514 is as close as I can get in the table to 25%. You're not going to find your percentages exactly in the table, and that's fine. You just get as close as you possibly can. But then to find the z-score for that, I would just go up to the top of that row and over to the left and see where, what two values intersect at 0.2514. And when I put them together, which is negative 0.6, and then on the top is 7, that's my z-score. Okay, so you have to look up your percentage in the table. Obviously, if your percentage was over 50%, you would need to look at the other side of the table, okay, where the z-scores are positive. That's my z-score. So up here, I'm going to plug in that negative 0.67 right here for the z-score. And now I'm just going to solve that equation for x. And the way we do that is multiply both sides by 75. So that'd be my first move. I need to get rid of this 75. So when I multiply those two, I get negative 50. And then, of course, I would add 1,500 to both sides. And I would get 1,450. Okay, so that means on the graph over here, this is 1,450. Now, when we solve these type of situations, we also want to include a statement of the context. So what did we just learn? Well, we just learned that 25% of light bulbs have a life expectancy of 1,450 hours or less. Okay, so that's a context statement. So I always want to be thinking about what did we just find, okay? Well, we figured out that 25% of light bulbs last 1,450 hours or less. Now, we don't have to use the table always to find these z-scores. Your calculator does this too, okay? And there's two calculators that are used in class. There's a TI-84 Plus, should put the plus in there, and the TI-83, okay? So how do you find these z-scores for a percentage using your calculator? Well, you always start with going to second distribution, okay? So that little blue key and then the key above the variables key, VARS. And you do that on either calculator. And then, last lesson we learned about going to normal CDF, number 2. Now we're going to go to inverse normal, which is number 3. Okay? So if you have your calculator with you, you could do this with me. On the 84 plus, you're going to get this screen. And let's do the same problem we just did. So I want to find out the 25th percentile, and when the percentage is 0.25. So I type that in for the area, and then I leave the mean and standard deviation as 1. Okay? If you're on the 83 calculator to the right, when you hit that inverse normal key, the inverse normal command will come up, and then it'll be blank. Okay? So you would just type in the 0.25, and you don't have to worry about the mean and standard deviation. And then in either case, you need to hit enter twice, or like you'd move it down to paste on the left-hand side here. Hit enter, and then hit enter again, and then that gives us the z-score for the 25th percentile. Notice we'll just round to 2 decimal places. That's perfect. It's negative 0.67 either way, which is what we got when we looked at the table. Okay. One thing to realize about the calculator, though, the calculator always looks up percentages as if they're on the left-hand side of the picture. Okay. So if somebody asked you, hey, I want to know the top 25% of ball life expectancies, you wouldn't inverse normal on the calculator 25%. You have to inverse normal what's on the left. So we would go inverse norm 0.75. And we would get 0.67 as our answer. Okay. Now notice that is the same number that we got before, but it's positive. And that's because of symmetry. Okay. If you think about looking at the bottom 25%, that'd be negative 0.67. The top is 0.67. That's one of the things we can use to our advantage in a normal distribution, is that there is symmetry. But realize on your calculator, if you type in inverse normal 25%, it thinks you want the 25% on the left. So it's going to give you a negative z-score. So just keep that in mind, okay? That if we ever ask for the top portion of the graph, we have to look up the left-hand side. And I'm going to do some examples of that coming up. So here's how you would do a problem. Let's start from scratch here one more time. So solving normal distributions for an x value. First, you should draw and shade a normal distribution. Then look up the z-score for the appropriate area. And of course, that's using inverse normal. I wouldn't use the table, okay? I would use your calculator. It's faster, more accurate, okay? And then you'll solve the z-score equation for x. So you plug in all the values and then solve. And then you should make an interpretation statement at the end to tell the reader what you found. So let's do this one. The life expectancy of a particular brand of light bulbs is normally distributed with a mean of 1,500 hours and a standard deviation of 75. It's the same prompt we've had before. The top 2% of light bulbs last how long? So first thing I would do, draw a normal distribution. Write in the mean and the standard deviation. Now the top 2% means I want this end, okay? Top 2%. So I'm going to write my z-score equation, and the x is what I'm looking for. I want that, how long does that light bulb last in the top 2%. I subtract the mean, divide by the standard deviation, and again, I need the z-score. So I'm going to use inverse normal, but here's the trick. You need to look up 98% on inverse normal to get that z-score. So on your calculator, you'd go to the inverse normal command, and you would type in 0.98. Okay, as the area. Okay, when you do that, the z-score you'll get is 2.05. okay? And that's important. If you had accidentally said the area was 2%, because they asked for the top 2%, the calculator would have given us negative 2.05. But that's on the wrong end, okay? And it would give you the wrong answer. So be sure you're typing in the left-hand area. So I would plug in 2.05 for Z, then multiply both sides by 75. That's 153. That's 153.75 equals x minus 1500. Then I'm going to add 1500 to both sides. And I'm going to end up with x equals 1653.75 hours. So of course now I would want to make a statement about what that means. So it means the top 2% of light bulbs have a life expectancy of 1,653.75 hours or more. Okay, that's the minimum. So that's how you would do a complete problem. Okay, draw the picture, look up the area, fill in the z-score, solve it, and then you should make a statement about what you found. Okay. We're just going to do a little further activity here where I have you just look up some values so I know you're for sure you're comfortable with this. So it says find the z-score for the given area. A says find the z-score for the 80th percentile. So again, draw a picture. Okay, the mean's in the middle. The 80th percentile would be over the mean, right? That's 50%. Is the mean. So 80% would be more than that. So I want to look up that. So I would do inverse. And I'm look up 80% since that's on the left. And my answer would be 0.84. Now here's an important thing. That 0.84 is not a percent. It's telling you that the z-score for this location is 0.84. So that spot is 0.84 standard deviations above the mean. So that's very important, okay? You're not finding a percent, you're finding the z-score. For B, it says find the z-score for the top 25% in a normal distribution. So I draw my normal distribution. Mean would be in the middle. The top 25% is over here. But again, we're going to look up on our calculators 75%. So I'm going to do the inverse normal command and look up 75%. And this is 0.67. Okay? And remember, that is a z-score, not a percentage. Okay? For C, find the z-score for the bottom 10%. So the mean's in the middle. Bottom 10% means this side, right? And that's exactly what my calculator looks up when I use inverse normal. So at inverse norm 10%, and that's going to tell me that the z-score is negative 1.28. Remember, that's a z-score, okay? It's not a percentage. And then D, one more, find the z-score for the 15th percentile. Remember, a percentile means at or below 15%, so 15% is here. And again, this is one where I just do inverse normal of the actual 15%. And I get a z-score of negative 1.04. Okay? So, good luck with inverse normal. If you have any questions, let us know.